Hi, I'm Connor Oberle, Product Manager for Rosemount's multivariable transmitters. And today in Emerson's interactive plant environment, we're going to explain how to calibrate a Rosemount 3051S multivariable pressure transmitter using a Trex device communicator. The calibration of Rosemount's multivariable transmitter is comparable to individually calibrating differential pressure, static pressure, and process temperature transmitters. It's important to note that Rosemount products need a zero trim calibration after initial installation to negate any mounting effects. And a full field calibration is necessary only if the transmitter is found to be out of specification. In this video, we will walk through the manufacturer's recommended steps to accurately and safely perform a full field calibration. Calibration and configuration should always be performed safely, and users should only remove the transmitter cover in approved and non-hazardous locations. Before beginning, always consult the product manual and your site's specific safety documentation. The tools we'll be using today are a Trex, an accurate pressure source, and a multivariable flow meter. We'll start by calibrating the differential pressure sensor, also known as a DP sensor. It's important that the DP sensor be calibrated at line pressure to negate any line pressure effects. The first step will be to connect a pressure source that is at least 3 times as accurate as the transmitter. Next, we will connect the Emerson Trex. The first calibration point will be a zero trim. A zero trim is a zero-based offset that provides a baseline for the measurement. For this reason, the equalize valve must be manipulated so that the high and low sides of the transmitter are experiencing equal pressure, or zero DP. To access the zero trim option on the Trex, first find the calibration page. Now select differential pressure trim. Then select zero trim. Once you have accessed the zero trim menu, follow the guided wizard. Once each step is complete, the zero trim has been successful. The next step is to perform an upper sensor trim, which should be calibrated to the transmitter's upper operating limit. The valve should also be manipulated so that the high side is connected to a pressure source. Now select upper sensor trim. The first thing to choose is the units, and then we will apply pressure to the transmitter. For this example, we will apply 100 inches of water. Now enter that applied pressure on the Trex and follow the guided wizard to completion. Once these procedures have been completed, the differential pressure sensor has been calibrated, and the next step is to move on to the static pressure sensor. The next step into calibrating a multivariable transmitter is to calibrate the static pressure sensor. The static pressure calibration follows a similar procedure as the DP sensor. The static pressure trims can also be accessed through the calibration page by selecting static pressure trim. For gauge transmitters, the measurement is referenced against atmospheric pressure and requires a zero trim and upper sensor trim. However, in an absolute transmitter, the procedure is slightly different. Since absolute transmitters are referenced against a vacuum, a lower sensor trim will need to be completed instead of a zero trim. All other steps remain the same. Just like the DP sensor, the calibration of the static pressure sensor is comparable to its single variable counterpart. Now that the pressure sensors have been calibrated, let's move on to the temperature sensor. This calibration is slightly different than the others, but is identical to its single variable counterpart. For temperature calibration, we will replace the pressure source with a resistance temperature simulator. The RTD simulator that we will be using outputs ohms, but you can use any accurate RTD simulator that you choose. We will start by first removing the RTD leads from the transmitter and connecting the simulators. Once again, go to the calibration page of the Trex and select the process temperature trim option. From here, we can follow the Trex guided wizards for the lower sensor trim and upper sensor trim options. Keep in mind, this process calibrates the temperature input on the transmitter and not the RTD itself. Once the lower and upper trims have been successfully performed, the calibration of all 3 sensors is complete. As we've learned, the Rosemount 3051S multivariable transmitter replaces 3 isolated single variable products within one device, reducing the number of calibration steps by 40%. To learn more about the Rosemount 3051S multivariable transmitter, please contact your local Emerson sales representative or visit our website.